Hello, in this video I will introduce the Go language. Go is a free programming language developed in 2009 by Google engineers Robert Geismar, Rob Pike, and Ken Thompson. The characteristics of Go are simplicity, reliability, and efficiency. Among these, Go places the greatest emphasis on simplicity. You will fully understand what this means as you see the code examples that will be introduced later. Go can be installed through the following link. After installing Go, you will need to install software to help with programming. Here, I will introduce Visual Studio Code. Visual Studio Code is a development tool developed by Microsoft and is currently the most widely used software. You can download Visual Studio Code from the link below. After installation, it is recommended to install extensions that will assist with Go programming. Search for extension in the menu on the left and install the one named Go. Now let's create and run a Go file. Open a folder and create a file named main.go. Then write the following content. And in the terminal below, enter the following command. Go is a compiled language. Therefore, to run code within Go, it is always needed to go through a process of compiling into an executable file. The go runs command compiles main.go and it creates an executable file in a temporary folder we don't know about and shows the result by running it. Since there is no content in the main function here, the file will terminate without any output. Now let's take a look at one of the basic concepts in Go, which is the module. A module can be simply described as a collection of Go packages. A Go packages is a collection of Go files, which I will introduce a little bit more later. A Go module is a kind of a system for distributing or compiling content written in Go. Earlier, we ran main.go without creating a separate module, but normally a module should be created first. The command to create a module is the following. Here, GoCalc is the name of the module you want to create. Typically, a module is created in the following state. In the root folder, there is a go.mod file containing information about the Go module and a go.sum file containing information about the packages required by the module. As mentioned earlier, a module is a collection of packages, and the root folder automatically becomes the root packages. All folders within the root folder automatically become subpackages of the root package. Now let's learn about packages. Simply, a package is a unit that groups Go files together. It can define variables, functions, and types. The name of the folder where the package is located automatically becomes the name of the package. The first line of every Go file belongs to a package should be declared the package it belongs to as follows. In fact, there is a special package among packages. It's called the main package. The main package is for generating an executable file and is not defined by the folder name. If a Go file declares the main package, that folder automatically becomes the main package. A Go file where the main package is declared is called a main file. It is recommended that a main package contains only one main file. More detail will be explained in another video while we look at the code directly. Next, let's learn about the types in Go. The basic types in Go are the follows. The Boolean types is related to 0 and 1 and true and false. Since Go is a strongly typed language, there are various types of integers. These types of integers are based not only on the form of the data that the type represents, but also the size of the data it consumes. There is also a floating point type called float, which is mainly used to represent real numbers. There is also a complex type that represents complex number and a string type that represents texts. There are many other types, but I won't introduce them here. Let's learn more types. An array is a type of list of values with a fixed number of elements, and a slice is a list of values with an unspecified number of elements. A map is a type that associates a key with a value, and this is similar to a dictionary type in Python. Go can also define functions as types. There is also a pointer type, and the pointer type refers to the address of the value stored in the computer's memory. Now, the struct type is one of the most important types in Go. A struct type is a type that groups several variables together. Each variable defined within it is called a field. For example, let's take a look at the struct type called graph options that will be implemented later. Below is the code to declare it. Graph option is the name of this struct type. Struct declares that this is a struct type. The code that follows provides information about the field of this struct type. For example, the nsub field stores the integer value. Next, xmin, xmax, ymin, and ymax stores value of the float64 type. Once you declare a struct type with a fields like this, you can also define methods for it. A method is a special function that can be called on a variable of that struct type, allowing free use of the field values contained in that variable. For example, the fixel method receives x and y as inputs from the point where it's called. However, in addition to these values, it can freely use the field values such as xmin, xmax, ymin, and ymax contained in the struct variable that calls it. The interface type is one of the most important concepts in Go. It is an abstract type that defines not its content, but the method that the type must satisfy. For instance, let's look at the interface type called additive. The additive interface must implement the three methods add, addInv, and zero according to this format. In other words, the additive type is different from struct type that defines the form of data. It acts as a wrapper for already implemented struct type. That means if a struct type has a method required by additive, you can wrap that as an additive type. Next, let's take a brief look at the concept of type parameters. When defining a type, there may be additional conditions required for that type. For example, let's say we define an interface called set. At this time, you may want to define an interface differently depending on input type of the contains method in the set. If you want to add a condition that the type declared as t must be an interface called element, you can write it like this. In other words, as long as t is a type that can be wrapped as an element, you can define set t as a new type. These type parameters can be used not only when defining abstract type, but also when defining struct types and even when defining functions. For example, let's say you want to define a function called max that returns the larger of the input value x and y. If the input type is not fixed and can be either int or float64, you can write it like this using type parameters. Using type parameters in this way, you can improve readability because you don't have to write similar code repeatedly. Abstract types can also be structured in a hierarchical manner. For example, let's assume you create an abstract type called point. You can make it satisfy all of the interfaces element, finite, and map as follow. That is, for a type to be a point interface, it must have the equals method of the element interface, the len method for the finite interface, and map method of the map interface. Here, since the map interface is defined using type parameters, you can see that the specific type was used as a value for the parameter type when adding to it. Finally, let's take a look at an actual example of implementing an abstract type. Let's implement the point interface we just discussed. Let's define simple vector as a slice of float64. This is fundamentally the same as the struct type with one field, but since it doesn't have any field, we will not call it as a struct type. However, even with this type of type, you can define methods. Let's implement the method required by point interface. First, map is a function that returns the ith value. Next, len is a function that returns the number of elements. Here, the built-in len function in Go is used. It returns the length of a slice. The equals method takes an argument of any type, q, and returns whether p and q are the same. First, you need to check whether q is of the point interface type. To do this, q is force converted to the point type. When written like this, the converted type is stored in QQ and the success of conversion is stored as a boolean in OK. If the conversion fails, Q is not the point type, so false is returned. If conversion is succeeded, the next step is to check the length of Q. If P and Q have different lengths, they are different, so false is returned. Finally, if the lengths are the same, compare the values of each ith element. Here, the element of point are defined as another interface called real. Since real encapsulates the element interface introduced earlier, you can compare their values using equals methods. If even one of the elements differ, false is returned. If no difference are found, true is returned. In the next video, we will discuss actual mathematical concepts and how to implement them in Go language one by one. Thank you.